Hello and welcome. Today we're on our final section, summarizing categorical data. Jumping right into things, we're learning about two-way frequency tables. Two-way frequency tables just compare two objects and their relative frequencies. This is also known as a contingency table. It's used to show the frequencies of data from a survey or experiment classified according to two categories, with the rows indicating one and the columns indicating another. Conditional probabilities, you can use a lot on this. Subcategories. The subcategories are the column and row headers that represent two different types of categories. In this case, employed and unemployed are being compared to junior and senior. So we can check out employed juniors, employed seniors, or people employed overall. Juniors, junior to senior comparisons. Joint frequencies are the values. That's a vocab word. Are the values of every combination of subcategories. So 8 is a joint frequency that represents the number of students who are employed and juniors. Marginal frequencies are the totals of each subcategory because they're on the margins. So 20 is a marginal frequency that represents the total number of juniors. In our first example, unisex names are names often used for both males and females at one point, and most common unisex names in the U.S. were Casey and Riley, with 176,544 Caseys and 154,861 Rileys. During that time, there were 104,161 males with the name Casey and 75,882 females with the name Riley. Organize the data in a two-way frequency table. Steps 1 and 2. Enter the given data into the table, then use the information to fill out the rest of the cells. So once again, the hardest part of our day is going to be putting data into a table. Let's grab a handy calculator. All right, well, we have the total number of Caseys and the total number of Rileys. So we can add these together to get the total of everything. So we have 176,544 plus 154,861. And you see we just did that one right here using totals. Oh, they got a typo. That W doesn't belong there. So we added the two totals together. So then they go through for total females, how they calculate it. Oh, we should go through everything. So for male Rileys, we're using the total number of Rileys and subtraction to get 78,979. To find our total males, we then add those two together to get 183,140. Now we go to the females named Casey. We use the total number of Caseys subtracted by how many males named Casey there were, and we get 72,383. And finally, we can add those two together to get total females. And our totals match this way and this way if we add them, so things are looking really good. Check it. For each cell, you can see your calculations are correct by calculating the value of the cell using different data. That's like we said, we can make sure our totals are correct by adding these two. Does it equal? Add those two. Does it equal? Technology. The Pew Research Center released a survey that asked whether participants thought technological advances in the future will make people's lives better or worse. Of the people interviewed, all right, so we got some data. 423 earned less than 50K per year. All right, that's our first group. 328 earned 50K or more. Of those earning, so this is less than 50K a year, 262 thought people's lives would get better. And we have another piece. 240 of those who earned 50K or more thought the same. Lives would get better. All right, let's put this data in. So we have 423 people earned less than 50,000. All right, so less than 50,000 is 4, 2, 3. 328 earned 50,000 or more. Of those earning less than 50,000, all right, 262 thought people's lives would get better. 240 of those who earned 50K or more thought the same. Okay, so we have 240. Now we can fill in the rest of the data. So let's go 423 plus 328 751. And then how many total thought better? 262 plus 240 502. Then of the 423 total, we know that 262 thought better, which means that 161 thought worse. Of the 328 total, we're to subtract the 240 that thought worse for 88. 161 plus 88, 249. 502 plus 249, 751. Perfect. A relative frequency is a ratio of the number of observations in a category to the total number of observations. A two-way relative frequency table, this is just an evolution of what we just did. Instead of using numbers, we're going to convert this to percents. Can help you see patterns of association in data. To create a two-way relative frequency table, divide each of the values by the total number of observations and place them with the corresponding decimal percentages. A conditional relative frequency is the ratio of the joint frequencies to the marginal frequency. Because each two-way frequency table has two categories, each two-way relative frequency table can provide two different conditional relative frequencies. All right, so to use this, many parents monitor their teenage internet usage. You should. The Pew Research Center conducted a survey of whether parents do or do not check on what sites their teens had visited and whether they are the parent of a teen between 13 and 14 or between 15 and 17. The results of the survey are as shown. All right. So part A, we have our table. And what you see is all of the frequencies are divided out of that total. and then the percentages add. 28.2% or between 13 and 14 do have their parents check on them. 13.2% do not. And how many kids were between 13 to 14? 41.4%. Do more parents check what sites their teens have visited, or do more parents not check? Look at the percentages. So does check is 61. So that is does check. 61% of parents do check the sites their teens have visited compared to the 39 who do not. Based on the data, do you think there is an association between teens' age and whether their parents check on their internet usage? Well, let's see. It's only like about a 4% difference. That's, meh. Could be anything. 4% difference really doesn't do that much. If we look at the totals between checking and not checking, more parents like to check. I don't know if age would really play into it. All right, next up. According to the U.S. Census Bureau, voter turnout describes how many eligible voters show up to vote in an election. Man, if we could just get 100% voter turnout one year. The table shows the number of eligible voters who did and did not vote in 2012 for the oldest and youngest eligible age groups. Organize the data in a conditional relative frequency table. Think about it. If the condition of the relative frequency table were whether a person had voted or not rather than age group, the joint frequency for people between ages 18 and 24 who voted would be 52.5. If someone claims that indicates 52.5% of all people voted in 2012 election were between the ages of 18 and 24, would that justification be correct? Absolutely not. That's using a if A then B statement, and then if B then A. That doesn't work. All right, we organized our data. Now we have to set up our frequencies. Interesting, they're not done over the total totals. Oh, we're doing joint marginal. Okay. So we have 13,275 divided by 25790. That gives us 51.5. We want 51.5. Then 11,344 divided by 16,724. Sorry about the beep. So we get our decimals. We can also take 100 and subtract that to find it. So what this is telling us is for the people ages 18 to 24, 48.5% voted. For those that are 75 and older, 67.8% of them voted. Which age group has a higher voter turnout? Well, for 18 to 24-year-olds, it was 48.5. And the percent of those 75 and older was 67.8. Based on the data, there is an association between age groups and whether a person voted. People aged 18 to 24 were more likely to not have voted than people aged 75 and over. That's it. Thank you so much.